Hi guys, so this video is just a quick recap of like all of Unit 3. So I'm just going to go through the main points and then a few examples of each. So the biggest thing to stress at the beginning is the two different forms that we have for writing logs. We can use log form or we can use exponential form. So knowing how to go between those two is really crucial. And that's just when we do our little loop, right? So if it's already written in log form, we want to go to exponential. We just do our loop. So this becomes 6 squared equals, finish the loop, 36, and we know that's true, right? And then to go from exponential to log form, we do our loop again, so this becomes log base 9 of 3, finish the loop, equals 1/2, okay? The biggest thing to stress is that our base and our argument have to be positive, okay? So this doesn't work, okay? We can't take the log of 0 because if you remember the graphs, there's actually an asymptote, a vertical asymptote at 0, so they never cross. So that doesn't work. And our base, just like this, we can't have that be negative. So those three things we cannot have. Okay? Next up are the 4 properties of logs. These are really important to know, especially when having to solve equations, so that's what we'll do at the end of this. These are the 4 properties. If you're multiplying what's inside of the log, you split that up using addition. If you're dividing what's inside, you're going to split it up using subtraction. If you have an exponent, that needs to get brought to the front, and then you multiply your entire expression by that. And then if you have any sort of square root, cube root, something like that, you rewrite that as an exponent, and then you bring that down. Okay? So just 2 quick examples on that. This first one, we have our exponent, our 3. You can do this 2 ways. You can either bring the 3 to the front at the beginning, or you can distribute the 3 on the inside. I'll show both ways. So if you bring the 3 to the front at the beginning, that gives you 3 times log x to the 6 y times y. And then when you split that up, that becomes 3 log x to the 6 plus 3 log y. And then you still need to bring the 6 out, so that becomes 18 log x plus 3 log y. Okay, that's one way. Another way we can do it is by distributing it in. Okay, so when we distribute in, right, we multiply our exponents. So this becomes log of x to the 18 y cubed. And then if we just jump a few steps right here, and we're going to split this up using addition and then pull our exponents out to the front, this becomes 18 log x plus 3 log y. And wow, would you know it, these two match. Okay, both ways work. Truly just your preference. Does not matter to me. Next one, we're going to condense it. Since we have our variables, not variables, coefficients up front, we need to bring all those up as exponents, okay? So this becomes log x to the 6 plus log y to the 6 minus log 12, oopsies, z to the 12, okay? So now we're going to combine these two using multiplication and then divide everything by z to the 12. This becomes log of x to the 6 y to the 6 divided by z to the 12. And we can actually split this up even more, since all of these exponents have a 6 in common. We can actually take out a 6. So this becomes log x times y divided by z squared to the 6. Because if you were to distribute this 6 back in, you get x to the 6, y to the 6, and then z to the 12. Okay? It's no big deal. They both do the same thing. Okay. Lastly, before we just go into solving them, I'm going to go over a few special cases. So that's when we're going to have, oh, hold on. There we go. These special cases, let's see. So these happen if our base and our bases are the same. So if we have a to the log of a, that cancels out, and so we're just left with x. Same thing. If we have log base a of a, that cancels out. Same thing carries over for natural log, since e is the natural log, or the base of ln. So e to the ln crosses out, natural log of e. You're just left with whatever the exponent is. And if you don't see an exponent, it's 1. Okay, so for this one, log base 6 of 6, that crosses out, and that's just going to equal x. This one, 3 to the log base 3 of x, that crosses off, and you're just left with x. Okay. Now I'm going to go through and solve a few problems real quick. Again, just as a recap, a lot of these problems are from the review that I posted, so if you're wondering where I got these, that's where. Okay, so first one, we need to loop. Okay, so we have x squared equals 25. If we square root both sides, we know x equals plus or minus 5. However, since this is our base, oh, let me let that zoom in for a second. There we go. Since we know that x is our base, it can't be negative 5, right? Since our base can't be negative, so this just equals 5. This one over here, we can cross off ln and e, so we're left with 2x minus 1 equals 6. 2x equals 7, x equals 7 halves. Okay. I'm going through these really quick just because this is supposed to be like a little recap. Shouldn't be too long. Alright, next one, you have to condense before you can cross off the log since they all have the same base. So since all of these are being added, we're going to multiply, right? So this becomes log base 3 of x cubed equals log base 3 of 8. Okay. We can cross off the logs since they're the exact same. So we have x cubed equals 8. So x is going to equal 2. Okay. Number 4 right here is a little tricky. So since they're not the exact same base, you can't really cross them off just yet. What's really important to look for is if there's a relationship between these two, between 4 and 8. We know we can write both of these as powers of 2. So 4 can be rewritten as 2 squared. Okay, and then x plus 1. And 8 can be rewritten as 2 cubed, right? So this becomes 2 cubed times 2. So we can cross off our bases. And then what we're going to be left with is 2x plus 2 equals 6. Okay, we get 2x equals 4. And then we get x equals 2. Okay. Number 5, we just need to loop. So we just get e to the 7 equals x. That one's just that simple, right? Because e is our base. Number 6, same idea as above. We're going to rewrite this using powers of 2. So 32 is 2 to the 5th. So this becomes 2 to the 5th times 2a minus 1 equals 2 squared. Cross off our 2's. We can distribute that 5 in. We get 10a minus 5 equals 2. 10a equals 7. A equals 7 halves. Oops. 7 halves. Alright, because you add the 5 and then you divide by 10. Last one, before you do anything and get rid of the e, you need to get rid of this 6. So divide both sides by 6. You get 2 equals e to the 3k. Now we can natural log, or do our loop. So we get the natural log of 2 equals 3k. And then just divide by 3, so we get k equals natural log of 2 divided by 3. Hopefully this clears up any confusion and just addresses all the main points. If you have questions, go ahead and email me or come to office hours.